Welcome to watching this video. In the first video, we have gone through some of the common mistakes that students make for inequality. In this video, we are going to continue to talk about another very common mistake that students make for the topic of inequalities, which cause them to lose unnecessary marks. And again, the core idea of the mistake is that students solve an inequality problem using the same method as how they solve an equality problem, which may not be true in general. So let us take a look at another example right now. So suppose we have this cubic equation which has already been factorized, and then I want you to find the roots of this cubic equation. So we will say, so x plus 1 can be 0, or x minus 3 is 0, or x minus 5 is 0. So from there we conclude that x can be equals to negative 1, or x equals to 3, or x equals to 5. Now the main idea why we can do that is because whenever we have a product of terms and the total product is 0, it means that at least one of these terms has to be 0. So it can be either the first term, x plus 1, or the second term, x minus 3, or the third term, x minus 5 is equals to 0. Now let us look at what happens if we change the equality into an inequality question. Now let's look at the same expression, just like I changed the equal sign to an inequality question less than 0. So some students will just blindly follow the same idea as how to solve for the roots. They will say, oh, I have 3 terms multiplied together is less than 0. Therefore, at least one of them has to be negative. So they will say x plus 1 is less than 0, or x minus 3 is less than 0, or x minus 5 is less than 0. So x must be less than negative 1, or x is less than 3, or x is less than 5. And they take the union of these 3 solution sets and conclude that therefore x must be less than 5. Now this answer is clearly wrong. Why is it wrong? So suppose we pick a value, say x is equals to 0. Well, x equals to 0 satisfies the solution set. But what happens if we place it back to the original expression? It will be 1 times negative 3 times negative 5, which will give me a positive 15 instead. So that means x less than 5, this solution set is actually incorrect. So how can we solve this inequality question? Well, what most schools will suggest is to use the number line method. So we draw a number line, and the value of x that makes each of the factor 0 are what we call the critical values or the special values. So the 3 special values will be negative 1, 3, and 5. And because our inequality doesn't include 0, so we will have to exclude all the 3 special values. Now, the first way is you can simply do by a graphical way, because this is a positive cubic curve. So a positive cubic curve will look something like this, passing through each of the 3 special values. And then we look at which interval the cubic curve is actually below the x-axis, which is the horizontal yellow line. So you can see that it's this region and this region. So the first region is to the left side of negative 1. The second region is on the right of 3 and to the left of 5. So my solution will be x is less than negative 1, or x is in between 3 to 5, excluding 3, excluding 5. An alternative method will be what we call the test sign method. So basically we have the whole number line, which is split up into 4 separate subintervals by the 3 special values. So for each subinterval, what we can do is we can sub in a suitable value of x into the original expression, and we just need to check the sign meaning whether the value is a positive or a negative value. So for example, let's say on the leftmost interval, you can try to sub in x as -2 into the original expression. If you press your calculator, you will get a negative value, so we put a negative sign here. Then between -1 and 3, well, we can sub in x equals to 0, and you can quickly calculate that you get a positive 15. So it's a positive value, put a plus sign. And then between 3 and 5, well, we can sub in x is equals to 4. And you can again use a calculator to show that it's a negative value, so we put a negative sign. And finally, for the last subinterval, we choose a value greater than 5, so we can say x is equals to 6. And you can again use a calculator to see that you will get a positive value. So overall, I want the inequality expression to be less than 0. So it will be the first interval, the subinterval, and the third subinterval. So my solution will be x below -1, or x is between 3 and 5. Thank you for watching this video, whereby we continue to look at some of the common mistakes that students make in inequality. Well, subscribe to my various channels so that you can be updated with all the latest tips and information on how you can easily score an A for your A-level math. Now, if you need any additional coaching from me, do contact me via my mobile number and we can discuss about how I can help you. Once again, thank you very much, and I'll see you in the next video.